Today I'm going to discuss the sandwich shop case for the Lean Six Sigma class and some solution or potential solutions to the problems. The problem is that the Lean Sandwich Shop has experienced quality and productivity issues, which are, of course, both tightly linked. Approximately 10% of their sandwiches receive complaints requiring a new sandwich. They fall behind in their orders throughout the day, and the annualized failure costs are as high as $120,120 due to discarding large amounts of expired food, which we'll refer to as scraps. So I categorize the goals for a lean transformation into efficiency goals and quality goals. The efficiency goal, the main efficiency goal, without trying to be too ambitious, is to deliver a sandwich order within 10 minutes. And the quality goal is to reduce scrap rate by 80%, resulting in an annualized cost saving, as I'm going to show you, of $96,096. The expected outcomes of this is reduced cost, increased customer satisfaction, indirectly leading to business growth, and improve employee morale, all of which point towards increased profits. As we all know, because we've seen throughout the semester, the Lean Sandwich Shop is open 10 hours a day, 7 days a week, 364 days per year. And this is a process map outlining how they make a sandwich. So basically, from the moment the customer places the order to the moment it's delivered, it's split into 7 taxes, all of which amount to 600 seconds of value at a time. And if we extrapolate this knowledge onto a value stream map, we can see that on the top and the left of the graph, we have basically the ordering activity, some of which is straight lined employee purchases in person, that is, and supplies are ordered weekly electronically, and they come into the shop at different points in time. But basically, the longest period of time without any arrival is 5 days. And of course, customers on the right place a demand of 600 sandwiches daily directly in person to the shop. Here we can see each of the different activities with their cycle times, the number of employees assigned to each of them, the hourly shift, which is pretty much 10 hours for everyone. And very importantly, in the timeline, we see lead time, which adds up to 5.03 days from counting from the 5 days of material delivery, and the value added time of 600 seconds. And you can already see that the proportion of value added time of that lead time is very, very low, which tells us that the PCE, the process cycle efficiency is very low compared to other organizations. As far as efficiency, we talked about a delivery and a goal of an order delivery in less than 10 minutes. And I think that this can be achieved by decreasing the lead time by grouping coordinated tasks. One way of doing this is this man-machine separation by incorporating toasting into the workflow. That will reduce the process time by at least 165 seconds, and also considering consolidating related tasks, which give us different time reductions depending on what we consolidate, and we could use that as metric. Second way of doing this is decrease motion waste, improving the workflow. And I would like to see a transit between stations or tasks of less than 5 seconds, and then a timely delivery measured as time from order to delivery of less than 10 minutes, and of course, no customer complaints. And if we look at this into a work balance table where we have a process time of which is the value at a time that I mentioned of 600 seconds, and a takt time of 60 seconds, calculated on the basis of this 600 sandwich demand. This tells us that we need normally, for no peaks or valleys in the work, 10 employees. And as you can see task cycle times, process cycle times, and there are a number of potential bottlenecks. One is the one employee on the third task, which is protein, adding protein. And very importantly here, the fifth task, which is the toaster station that has 3 employees, that if you look at the work combination chart below, you can see that there's a long period of 165 seconds where basically there are 3 employees that could be doing something else, or that might be redundant. So I propose a different workflow where the customer is in the center, and there's 3 people taking orders, and of course the task cycle time doesn't change, and neither does the process cycle time, both of which I'm going to call TCT and PCT respectively. The second station, receive and select bread, has no problems, or had no problems, and will have no problems with 1 employee. It's a fast station. Now the other 2, the green stations, I consolidated the protein and vegetable tasks on the one on task number 3, and the wrap and delivery task on task number 4. And there is no toasting task or station per se, but the station or task 3 puts the sandwich in the toaster after adding protein and vegetables, and station 4 will get the sandwich out of the toaster when it's ready for wrapping and delivery. And this reduces the number of tasks to 4, the process time to 490 seconds from 600 seconds, and the number of employees from 12 to 10. And importantly, I incorporated a transit time of 5 seconds from the station to the toaster, and the toaster back to the station. And here you can see the work balance table has changed, and most of the activity is actually in where I think it should be at task 3 and 4, and we can process customers quite efficiently in the task 1 on the left side, on the task 1 and 2 and of course with a lower process time we would need less employees, which will, as I've shown you, that's a reality. We will use 2 less employees than we had. And then we eliminated the toaster as the a bottleneck in this whole process, right? So the throughput and financial assessment, with a new process time of 490 seconds, we can increase productivity from 600 to 730 sandwiches per 10-hour shift. That translates into a TPH of 7.3, which is up from 5. And this translates into, annualized cost savings of 109,200. That is down from 655,200 to 546,000. And let's go to a little bit, let's go to quality now. As in this Pareto chart, you can see that the 40%, the majority of the problems with quality have to do with cold sandwiches or the wrong parts included in the sandwich. But I think that the cold sandwich is a big deal. And if you look at the risk assessment matrix, you know, these incorrect protein, correct vegetables, quality standards, and cold sandwiches are major issues in the priority list, right? Which is consistent with the Pareto chart. So what we suggest for quality improvement is to increase, as we have a larger number of employees at the end of the process, that is in tasks 3 and 4, because we consolidated tasks, this will allow us to designate an alternating quality officer that will regularly audit based on high scoring variables in the risk assessment matrix, and also efficiency matrix like TCT and PCT. The quality officer will receive an incentive bonus of $50 per audit, and I accounted $500 in the prevention cost in this cost of quality worksheet. And as you can see here, the annual failure cost based on a 10% scrap rate is $120,120. And with a target reduction of 80%, that is from 10% to 2%, the annualized savings is $96,096 with prevention cost of $500. That gives us an interesting ROI. So in conclusion, simple modifications can result in increased efficacy, revenue growth, and annualized cost savings estimated at $109,200. Quality improvement can contribute to better workflow efficiency and decrease waste. A reduction in our failure scrap by 80% can result in annualized cost savings of $96,096. And with this, we can improve the way we work, we grow our business, and decrease costs of more than $200,000 a year with very, very feasible lean modifications. And with this, I'm going to stop the recording. Thanks for listening.